let's continue with our prediction section about our demo file. So here we have our sample data is from the birth table. So we already get rid of some outlier. So here we only have the pregnancy date between 225 to 325. So then we have the birth weight on the y-axis. So from here, yeah, let's assume, of course, we are doing the regression model. So the first thing we need to see the correlation, right? Before we run that, just see the data here. What correlation number you are expecting or you guess for before we run that. Okay, so of course we have that the code here. We can run it, but I just want to make let you know, sometimes make a guess before you run that. So for me, I will feel like they kind of 50%, so maybe 0.5. Okay, then we got a 0.422. Okay, so that's you can see here the slope may be like that. Yeah, because the birth weight, the pregnancy day is 280, the birth weight is about, yeah, they have 120 on a lot of different variation. Okay, so then let's have our scatter plot again with our regression line, the best fit line here. So that's our sample data set and that's our regression line. Like earlier we say from the regression model, one thing we want to do is it helps us, maybe we can do some prediction. So according to the regression line we have, let's see about 300 days, what is the birth weight will be. Okay, so that's about 130. Okay, but that's get the exact value. Okay, so we see the prediction from the given x value. Okay, given x value here. So then we just try the corresponding y to find the estimate y. Of course, this one, as long as we know the slope and the intercept, so that's why we can get our estimate y. Okay, so then the same thing. So the prediction, we have the table name, x-axis and y-axis, and specify the x value. Okay, so then we can return our predict data. So here, if we want to find the prediction at 300, so we just specify our table name and the xy column and the x value. Okay, also like earlier we said, yeah, it's about 130. So then we continue to see this graph we have, right? So that's here just still the same thing, our sample data set and our regression line. So we just want to show you, yeah, that's the vertical distance we are looking for. So we plug in the x value to get the estimate y. So is this one a good prediction or not? That's the one way to get the prediction. But we go back to see the prediction. Of course, if we only have one sample data set, one regression line, so that's the prediction we get is one value. But just like we talked about before, the lecture before, we try to have our prediction since we only have one estimation. It's kind of, we don't want to have just one number, one exact number to kind of say this is the value we predict. So for our prediction, we try to provide an interval. Yeah, so when we talk about interval, then you think about the confidence interval and everything, right? Right, so just like what we did before. Before, the lecture before, we talked about the bootstrapped. We only have one sample data set. We can just resample that without replacement. Then we make many times the resample data. So then according to the prediction of the y, if we're using that regression line, we go through each resample plot. That means each resample plot, we have one regression line, then we have one prediction y, prediction value of y. So we repeat this resample regression line, find the prediction number. So then we draw an empirical histogram for all the prediction. Of course, when you hear about the empirical histogram, you know we need to do that many times, more than 100, more than 1,000. So after we have that empirical histogram, so in that 95% confidence interval, that's our range for our prediction of Y. That's we call our prediction interval. That's approximate 95% confidence interval for the height of the true line at X. So how to do that? Right, of course, we need to use our Python to help us to do the resample and everything. Okay, so we use the bootstrap again. So back to our sample, our demo file. Let's do step by step. Instead of we do 1,000 times, we need to show you only just one time, couple times, how we do the resampling. So here, actually, you don't have to complete understand how the code did, but if you want, you can try to read if you major in computer science. Okay, but the most important thing you just need to know here, we just try to make the plot, okay, for our resample data. Okay, so the most important thing is understand what is the output data is. So then you can see here, actually, we just have our original data set. Okay, so then according to the resampling, you see here, right? So then we have our birth table. Then we call the sample function. So we resample each time. So here actually we only do 6 times. So then each one we just do the scatter plot again. So you can see here, the screen is small, so we just have 4 first. They look very similar, but if you see the detail, they still have some differences. Okay, right? So that's we resample with replacement. Okay, so even the distribution, the shape look very similar, but if you detail, you go to see each sample, they are different. Okay, so that's our resample data. So we just use the graph to show you first. So then the next one, we just want to show you, right? Let's do our resample for 4 times. Okay, so we do 4 times. Each time we resample. So then we just call the prediction function earlier, right? Remember, you have your table name, you have your X column, your Y column, then your input X together predict Y. Okay, so we're just using the resample 4 times. Let's compare the predict Y. Okay, so here actually they just display at the beginning first. So then you can see they are all around 130, but slightly different. Okay, so then if we put each resample in the graph, okay, so that's what we say, that's the input X, 300. So that's corresponding Y. Okay, so that's the first resample. Then the second resample, then the third one. Okay, so yeah, they are pretty close. But one thing, just like we say, we really want is when we do the prediction, we are not just give one exact value. Okay, instead we want to give a range. Okay, so then continue. Of course, at the end we want to make sure we can do our simulation. Okay. So one thing is here, the next example, we just want to show you, okay, after we have that resample, okay, so how about we just make the line first? Okay, so this one actually, we do 10 times. Okay, so each time we do the 10 times, and we find the slope and the intercept. Okay, so then we just have, this one actually, we have our data in 210, 300, and 320, but actually we just mark on the 300. Okay, so you can see if we have the resample 10 times, yeah, but they are very close for the predict data, right? And we want to show you an interesting thing is here. Okay, you see most line, they are crossed over here. Then this one is X about 280. So y about 120. So then let's run our average for our x column and y column. It happened here, x column average is 280. Okay, then your y column is almost 120. Yeah, so here is 119.6. So that's why we can show you, right? You see, even each resample, they have slightly the regression line is different, but they all pass the average for the point with the average x and y. And also we can see from here, the estimation will be very close, prediction very close. When they go further, you see they spread out for each line as well. Yeah, so that's interesting we want to show you as well. Okay, so then, yeah, so we will see, of course, we want to find our interval. Okay, but the first thing, let's continue to have our data here. Okay, so this one, not earlier we showed you is the 10 regression line. So here, the same thing, we do the 10 times regression, 10 times the bootstrap resample. Okay, so then this time we get not only 300, we got more than 300, 309, and less than 300 at 291. Okay, so then you can see each time we have different regression, different slope, but they are all very close by. Okay, so different intercept. Okay, so then you can see at 291, so they are all, of course, in the range. Also, if you observe the data here, the smallest one is 124, so then to 127. But this one, you see the smallest one is 28, then they up to 32. So if you're 309, they are even bigger range. So they are as small as 33, then as big can be 37. Okay, so this one actually we just want to show you, see from here, on 290 something to 300 and 309. Okay, so they spread out for kind of bigger range for our prediction. So using the table may be not so easy to see, but here we just show you if you see the line a little bigger. Okay, so that's the there they go a little wider. Okay, yeah, but the most important thing we want to show you here is they do have, yeah, so here we just make the range and we only have from 291 to 309. Okay, so you can see from here, you can easier to see the range here is about 4. So here is about 4, but then here will be more than 4. So they do have spread out because the average is about here. Okay. Okay, so that's our demonstration. But one thing is we're just using different kind of graph to show you those regression lines look like. But like earlier we said, the most important thing is we want to have our prediction interval. We want to have our sample set to be resampled 1,000 times. Yeah, so that's do 2,500 times. Okay, so according to earlier the code we have, right? So we have our prediction we need to get. Okay, so then, so of course you see, remember we told you our prediction need to be in a range. So then we make an array for that. Okay, so we do 2,500 times. Of course, each time we need to do the resample. Okay, so after we get the resample, then we have our prediction value. So we just passing the resample table. X and Y still the same, yeah, according to the input here. So then you have your new X, Y. So this new X just on the input X, we try to find the predict Y. Okay, so then every time, of course, we need to add our prediction Y to our predicted Y to our prediction array. Okay, so this part is we do the resampling. Then, of course, all the prediction, we need to make that in a histogram. Okay, so then here, so then we will have histogram plot. Okay, but one thing also we want to show you on the 95% confidence level. So that's why we show you the left and the right. Okay, so then after we run this the bootstrapped function, So then we run on the 2500 times simulation. Okay, so then you can see they go with the while. Okay, so since our video is almost 15 minutes, so let's take a while to see the output. Then you can check the output as well.